The Bayraktar KIZILELMA unmanned combat aircraft program has quickly become one of Turkey's most ambitious defense initiatives. Built by Baykar, the platform represents a dramatic reimagining of future air warfare, combining low visibility design, autonomous decision-making, high-gravity maneuverability, and cost-effective mass production. This event marked the first time a Turkish unmanned combat aircraft successfully conducted a high-precision strike maneuver, using a domestically developed beyond vis. More importantly, the test demonstrated the convergence of two strategic ambitions: fielding next-generation unmanned combat aircraft with autonomous combat capabilities, air-to-air combat, including medium-range interception missions, suppression and destruction of enemy air defense systems, deep strike operations with low autonomous or man-in-the-loop decision cycles for coordinated combat. The Gokdogan missile was developed by Tupatek Sage as part of the indigenous GGK family of air-to-air missiles. Designed as a beyond visual range weapon, the system conceptually competes with globally recognized missile systems such as the AIM-120M. Gokdogan incorporates several key technologies: active radar guidance for terminal phase tracking, imaging, and an improved monopulse radar seeker. Powered by a single AI-25 TLT turbojet engine in its initial configuration, the KIZILELMA is capable of reaching transonic speeds. With future variants expected to reach supersonic speeds, its flight control software, a key feature of Baykar's unmanned systems, allows the aircraft to operate with high maneuverability, even under significant making it ideal for missile tests requiring high stability and accuracy. Its modular design allows for internal and external transport on platforms such as the Khan National Fighter Jet and the F-Shilo ZGR modernization program. Integrating a sophisticated BVR missile into an unmanned combat aircraft poses numerous challenges. These challenges include aerodynamic modeling, safe separation analysis, seeker signal compatibility, and flight control synchronization during high-speed maneuvers. Recent tests demonstrate the successful resolution of these challenges. The KIZILELMA mission computer is synchronized with the Gokdogan missiles avionics. This ensures accurate mid-course guidance, targeting data transfer, and launch authorization. During the test, the KIZILELMA maintained a stable flight profile while initiating the firing sequence. Video footage shows a smooth release from the hardpoint, a critical moment where flight instability can compromise accuracy or safety. After separation, the Gokdogan activates its propulsion system and begins guided flight toward the designated target. The missile's radar seeker and guidance algorithms demonstrated responsiveness and accuracy. Telemetry confirmed that the missile followed the programmed interception path and reached the intended penetration target, marking the success of the first integration test. Conventional UAVs are not designed for air combat. With this test, the KIZILELMA became one of the world's first drones capable of firing BVR missiles, placing Turkey among a select group of nations pursuing unmanned air superiority. By combining an advanced, domestically developed UCAV with a national BVR missile, Turkey reduces its dependence on foreign suppliers for crucial air combat capabilities. It also ensures adaptability during embargoes or geopolitical tensions. This test moves the KIZILELMA closer to fully autonomous air combat. In a future operational concept, swarms of unmanned combat drones armed with BVR missiles could operate alongside manned jets, creating layered formations and overwhelming enemy defenses. Both the KIZILELMA and the Gokdogan missile have significant export value. Many countries are seeking advanced yet cost-effective air combat solutions. Unmanned platforms capable of BVR combat could reshape the global defense market, especially for countries without access to fifth-generation fighters. While the missile launch is a crucial step, several additional phases remain before the system becomes operational: high-altitude and high-speed live-fire tests, simultaneous multi-target combat scenario testing, full integration with an onboard AESA radar system, internal missile launches to enhance stealth capabilities, and networked combat with manned aircraft, Khan, F-16. Once these are completed, the KIZILELMA can enter a limited operational role in the Turkish Air Force. Its combination of stealth, affordability, and autonomy positions it as a strategic multiplier in modern air combat. The successful test of the Bayraktar KIZILELMA and MISA is more than a demonstration of technological advancement. It is a glimpse into the future of air warfare. It reflects Turkey's determination to build a sovereign, integrated, and highly adaptive combat aviation ecosystem. As the KIZILELMA approaches full operational capability, it symbolizes the transition from traditional drone warfare to a new era in which unmanned combat aircraft not only support missions but also actively participate in air dominance. In many ways, this test represents the opening chapter in a new narrative where advanced autonomy, indigenous engineering, and strategic vision converge to define next-generation air power.